Hello everyone, welcome to the past paper discussion. So we are starting a new series in application and interpretation, paper 2, number 2022, past paper. So let's get started with the first question. And this question is related with bivariate like statistics, and we are going to do probability over here and some binomial distributions, right? So here at Mirabuka Primary School, a survey was found that 68% of students have dog and 36 have cat, and then 14 have both dog and cat. So this information, if you convert into Venn diagram, this is how it will look. So here we can see some unknowns, M and P and Q. And we need to find the value first. And some more questions is there. So totally it's gonna fetch you 15 marks. So let's get started. Okay, what they have given? Dog 68%. So it's dog and dog only, that two have a difference, right? And then cat 36%. Then both is 14%. So whenever they say both, that comes in intersection part, right? So n is equal to 14%, right? And here they simply said dog is 68, but M means only dog, right? So M refers only dog. How should I find it? So 68% means all together. Maybe cat M plus N is actually the 68. And cat is nothing but N plus P. Now I know what is N. So it's quite easy to find the rest of the values like only cat. So M plus N is 68%. And what is my M? Equal, N is 14, right? 68 minus 14, which is 54%. Right? We got M. Then N plus P is equal to 36%. And we want P. P is 36 minus 14%, which is 2 and 22%. This is my P. Now, what is Q? Q is out of the box, so nothing. They don't have either neither cat nor dog, right? So that is, since it's given in percentage, the entire survey is taken as 100% and just remove this M and P all, right? So to find Q, 100 minus, remove the cat only, dog only, and both. So this will fetch us around 100 minus 54 minus 22 minus. So it's going to be 90 here. So 100 minus 90, it's 10%. So these are the values. Everything is in percent, right? M is 54. You just list it out. N is 14, P is 22, and Q is 10%. That's simple, and this is going to help the upcoming problems, right? Let's go. Right. And next question. In the same information, find the probability that a randomly chosen student has a dog but does not have a cat. Okay. So has a dog but does not have a cat means they are asking for purely purely dog. So this is the region. We can say only dog. That's what they mean. Okay. So if I include this portion, those who like cat also will come under that. So we ignore it. So has a dog but doesn't have a cat is only this portion. And this number we already find it. It's 54%. So it's quite direct. It's 54%. Right? That's simple. Next, what is the probability that a randomly chosen student has a dog given that they do not have a cat? So this is a conditional probability. Probability of, okay, I'm going to randomly pick a student. He should have a dog. That is the probability I'm looking for. Like, I'm not going to take the entire survey the entire students who will involved in the survey, given that they do not have a cat. I'm gonna randomly choose a student who does not have a cat. So not all the people. So probability of dog, given that he do not have a cat, I'll just use the prime. C means cat, C dash means prime. Okay, so the conditional probability formula go like this. So it's quite simple. So what is given? Given number of people is those do not have a cat. 36% have cat. So do not have cat is 100 minus 36%. Okay. Then from this people, I'm going to pick who has a dog. And here they didn't mention they only have a dog or something like that. Right. So here we will go with 54% has a dog. 54. So 54 over 64. You can simplify as 27 over 32. Or you can just convert into decimal. When you divide this, you will get 0.84375. And here you might get a doubt. Why it's they didn't mention dog only. But why? So most of you will make a mistake by putting 68 here, but it is not. Because we are taking from, those do not have a cat, right? So this 14 will not be included because they have a cat. So that's why it's 54, not 68. So you can represent in this way or in %84. Any answer is accepted here. That's simple. Right? And next, separate description starts over here. Let's go. Before C. So each year, one student is chosen randomly to be the school captain of Mirabuka Primary School. Tim is using a binomial distribution to make predictions. Okay, so he's using binomial distribution. And to make the predictions, what is the context? How many of the next 10 school captains will own a dog? So for the next 10 years, like how many school captains will have a dog? That is his predictions. So he assumes that the percentages found in the survey will remain constant. So whatever we deal so far, the dog, cat, and all the count, and the probability stays the same. And the events being a school captain and having a dog are independent. They are independent events. One will not affect the other. Right? So now using Tim's model, we need to find the probability for the upcoming 3 problems. Okay, he used binomial distribution. First one, 5 school captains will have a dog. So we are doing for the next 10 years so that the probability that 5 school captains will have a dog. Okay, so probability of having a dog is 68%. I hope you might remember that. So that is what first. It's not 54. I will tell you why. 68% because they didn't mention either it's just a cat, just a dog, right? So they mentioned dog. So even if they have a cat, that is not a problem, right? So that is why here binomial distributions, of course, we need number of trials and P and then bounds, correct? And it's exactly 5 we are dealing with. So binomial probability density function we will use, right? So P is 68%. You can write it as 0.68. And number of trials is 10 for the next 10 years. And we are looking for 5, right? So these are the things we should take in count. 5, the probability of success to have a dog and number of trials. Now the rest can be done with the help of GDC. Now let me just switch to the calculator page. Quite simple. We have all the data. Go for calculator menu. In the probability, go for distributions. We have a lot of distributions here. We are working on binomial and you might see 2 things. Binomial PDF, binomial CDF. So choose PDF when you're solving for exact. We are solving for exactly 5 captains. So PDF. Number of trials we have is 10. Probability of success is 0.68 and X value is 5. So this is what we got. Now we can just take it over there and interpret the result here into the solution page. Okay, So now you can just, they have mentioned, so X is distributed into binomial distribution as 10, 0.68, right? And we are solving for P of X is equal to 5. And this will give us, this is the result I have, 0.12 is fine, or 1, 2, 3, anything can be. So this is the result of the first part. Hope it might be clear. Now, that's simple. Now we have 2 more questions based on the same. Okay, go with the 3 significant figures. Right. So now next, in the same binomial distribution, for the same description, we are solving for 2. More than 3 school captains have a dog. Again, it's binomial distributed. And then 10 trials, like 10 years we are, and more than 3. So your X is greater than 3. Then have a dog only we are solving. So the probability of success is same 0.68. Right. Now again to the calculator page, we can just go and solve this part. Here we go. Right. So this time X is greater than 3 was given. So we have to use binomial CDF. So number of trials is 10, and you can see the difference over here, right? Probability of success is 0.68. Lower bound. Okay, I am solving for X greater than 3. So like more than 3. So more than 3 means the lower bound is more than the 3. So it is 3 point, I should give in that way. So you should give 3.00001. So you can just put upper bound is like a very big value. You can give like 999 and so on. That's it. We got this answer. So binomial CDF, and this is 0.94497, right? So moving to the solution page, let's interpret this result. So we got probability of the required thing. Having more than 3 school captain, have a dog, is 98.4%. That's a great probability, right? And the last part in this description, which is given, exactly 9 captains in succession have a dog. Okay, so here we have to think a little different. So we are selecting captain 1, 2, 3 till 10 captains. C1, C2, C3, C4, C5, C6, C7. Okay, like till 10. Now, exactly 9 captain in succession should have a dog. So first, from the first captain till 9th captain, that is the one part. Otherwise, there might be this. Only 2 combinations possible here. Right? That's simple it is. Otherwise, from the second captain, first captain doesn't have a dog. We can think in that way. From the second captain till the 10th captain might have a dog. So these are the 2 combinations. Is any other combination possible? Like, let's imagine from the 3rd captain till 10th captain will have a dog. Yes, it can be possible, but that don't count 9 captains. It will have 8. So that's the problem. Only 2 combinations possible. Now, how to calculate? These are success, probability of success. And 10th captain should not own a dog. That is the important thing. So the first one will go like this. You will apply the product rule here. So 0.68 power 9. The probability of success power how many times? So consecutively 9 success times, then the probability of fails. It should fail, right? Because exactly we need, and it is 0.32. How I got this? Very simple. Probability of success is 0.68, means probability of failure is 1 minus that value. 1 minus 0.68, which is 0.32. And we can just solve this using our calculator, normal calculating function. So I'm not showing it. We can just directly multiply and put this. Yeah. And okay, better I will show you so that you won't make any error. So in the normal calculator, scratch pad, you just go and raise it to the power 9 and give the input 0.68 times 0.32 only once. So this gives us a probability and it's a very low. It's very close to 0 only, right? So this is the thing we have. Moving to the solution. So we got this. Okay, what happened to the second case? Second case is also same, but first I have a failure, then the ninth is all the 9 upcoming or success. So it's nothing but same like a commutative. 0.32 times 0.68 whole power 9. So better you just multiply this with 2. Correct? And when you multiply this with 2, we will get around 0.0199. Okay. So that is the required probability, which is probability that exactly 9 captain in succession have a dog. Yeah, it's quite big, but yeah, that's it. This is the probability, and when you convert it, it's just 1.9%. And that's simple. Okay, now the last part, it's kind of a reasoning. Like just keep all the things that we have did in this problem. Let's go. Here, there is a description here. Each year, one student is chosen randomly to be the school captain of Mirabika Primary School. Tim is using binomial distribution to make predictions out of next 10 years school captains who wants a dog. And all the percentages that we have solved initially, it will remain constant for the 10 years. Now, John randomly choose 10 students from the survey. Okay, so now John is picking. First, it's Tim was solving this, right? So Tim make a model. Now, John randomly chooses 10 students from the survey. State why John should not use the binomial distribution to find the probability that 5 of these students have a dog. Right? Okay, so let's see why. So he picked 10 students from the survey. That is one thing we can note. Like John is doing like this. 10 students from the survey. Okay, in the survey, I have combination of people. Those have dog, cat, both, neither. Right? And he is picking 10 students. What is the probability these students have a dog? 5 of the students have a dog. This is what he's going to predict. Probability that 5 of these students have a dog. Yeah, we can solve this, but why we should not use binomial distribution, right? Probability of 5 of the students have a dog. Okay, the reason is, let's see, he's picking 10 students from the survey. Like, let me name 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Randomly, he's picking 10 students. Okay, so here there might be a chance this third student might own a dog. Okay, it will be 0.68, the probability. The 10th student might not own the dog. So the probability will be 0.32, right? So this is the way it will fluctuate. The probability is not constant. The probability should be constant for the binomial distribution, right? So that is why this won't work. right? So due to the fluctuation of probability, you can say, or the probability is not constant is the best way. That's the reason. So reason, the probability is not constant. Right. That's it. This completes the solution of the entire problem. So it's very easy to solve, get the 15 marks. That's quite simple concept over there. Uh, so stay in touch. Thank you so much for listening with us. Keep learning. Let's meet in the next video.